What if I told you that one single day, just 24 hours, could trigger your body to start regenerating its own stem cells, clear out decades of cellular damage, and begin burning the stubborn fat you've been trying to get rid of for years? Not with a pill, not with a surgery, not with an expensive protocol. Just 24 hours of doing something your body was biologically designed to do. Now, I know what you might be thinking. I've tried everything. I eat well. I exercise. I take my vitamins, but I still feel sluggish. I still carry this weight around my belly, and I still feel like I'm aging faster than I should be. And here's the truth that most people never hear from their doctors. The problem isn't your effort. The problem is that your body has never been given the right signal to switch into repair mode. Because here's what's really going on inside your body. Every single day, your cells are accumulating damage. Old proteins are building up. Mitochondria are getting worn out. Stem cells, the regenerative seeds of your entire body, responsible for repairing your tissues, your immune system, your blood, your organs, are sitting dormant. And one of the primary reasons they stay dormant is something you probably do every 3 to 4 hours without even thinking about it. You eat. Every time you eat, especially carbohydrates and sugar, your body releases insulin, and insulin is like a light switch. When it's on, your body is in storage mode. It is building, storing fat, running on glucose, and keeping mTOR, a growth signaling pathway, fully activated. And when mTOR is fully activated, a process called autophagy cannot turn on. And when autophagy can't turn on, your stem cells can't regenerate. Think of it this way. Imagine your body as a city. During the day, the city is bustling, traffic everywhere, shops open, people moving, nothing can get repaired, the construction crews can't work, but at night, when the city goes quiet, that's when the maintenance teams come in. They fix the roads, remove the debris, replace the old pipes, and build new infrastructure. Autophagy, and the stem cell regeneration it triggers, is your body's night shift crew. And for most people living on 3 meals a day plus snacks, that crew never gets to clock in. Today, we are going to change that. I'm going to walk you through exactly what happens inside your body during a single 24-hour fast, hour by hour, and why this protocol is becoming one of the most scientifically validated tools for cellular regeneration, fat loss, immune renewal, and biological anti-aging that we have available to us right now. I want to be clear. This is not a starvation protocol. It is not extreme. It is not dangerous for healthy adults. It is a precise metabolic intervention with a growing body of research behind it, including a landmark 2024 study from Columbia University that revealed something extraordinary about fasting and stem cell biology that I'll share with you shortly. And before we dive in, if this content is helpful to you, if you're learning things today that you've never heard from your doctor or in your health research, consider subscribing to this channel. I post content like this every single day. Practical, science-backed health information that you can actually use. Let's start with the foundation, because if you don't understand autophagy, none of the rest of this will make sense. Autophagy. The word comes from Greek, auto meaning self, and phagy meaning eating, self-eating. And before you scroll away, let me tell you, this is not a negative thing. This is arguably the most powerful regenerative process in the human body. It is so important that the scientist who discovered how it works, Yoshinori Ohsumi, won the Nobel Prize in Physiology or Medicine in 2016. Here's what's really going on inside your body during autophagy. Your cells, and this happens in virtually every tissue in your body, identify old, damaged, dysfunctional components. These include misfolded proteins, worn-out mitochondria, cellular debris, damaged organelles. The cell essentially packages this waste material, breaks it down, and recycles the raw components to build new, healthy structures. It's like your cells running an internal recycling program, deconstructing what's broken and rebuilding something better. Let me explain this with a simple analogy. Imagine your kitchen after cooking a big meal. There are dirty dishes, scraps on the counter, old containers in the fridge. If you never clean it up, over time the kitchen becomes unusable. Things start to rot, bacteria grow, efficiency drops. That's what happens in your cells when autophagy is suppressed. But when autophagy kicks in, it's like a deep cleaning crew coming through. Everything gets scrubbed. The old gets removed. The kitchen is ready to perform at its best again. What the research shows is that autophagy is central to almost every marker of healthy aging. Low autophagy is associated with accelerated aging, increased cancer risk, neurodegeneration, chronic inflammation, and critically, stem cell dysfunction. A 2025 review published in Cell Regeneration found that the loss of autophagy in stem cells results in loss of quiescence, premature aging, and diminished regenerative potential across tissues. In plain terms, when your cells can't clean house, your stem cells stop working properly. And here's the metabolic key. The primary trigger for autophagy is a drop in insulin and a drop in mTOR activity. When insulin falls, as it does during fasting, the cell gets a signal that nutrients are scarce, and it begins to conserve and recycle. AMPK, an energy-sensing enzyme, gets activated. mTOR gets suppressed, and autophagy turns on. This means that the single most reliable way to activate autophagy and the stem cell regeneration that follows is to stop eating long enough for insulin to fall and stay low. And based on the current science, that threshold for meaningful autophagy begins around the 16 to 24-hour fasting window. Now, I want to give you something practical right here before we move on. If you've never fasted before, you don't need to start with 24 hours. You can begin by extending your overnight fast, stop eating at 8 p.m., and don't eat again until 12 p.m. the next day. That's 16 hours. That is enough to begin the process. It's a place to start. But here's what most people don't understand about why their body can't seem to tap into this regenerative state, even when they think they're eating healthy. Most people understand that insulin is related to blood sugar. But what they don't understand is that insulin is one of the most powerful aging signals in the human body. Every time you eat, especially carbohydrates and sugars, your pancreas releases insulin to shuttle glucose into your cells. That's normal. That's healthy. The problem isn't insulin itself. The problem is chronic, sustained, elevated insulin, the kind that comes from eating every 2 to 3 hours, snacking constantly, consuming ultra-processed foods, and loading up on refined carbohydrates at every meal. The modern eating pattern. Here's what's really going on inside your body when insulin stays elevated. mTOR, the mammalian target of rapamycin, remains activated, and mTOR is essentially the master growth switch of your cells. When mTOR is on, your body is in anabolic mode, building, growing, storing. That's fantastic when you're a teenager building muscle. But when you're an adult with already sufficient cellular mass, chronically elevated mTOR means something very different. It means autophagy stays off. It means cellular cleanup never happens. It means damaged proteins accumulate. Old mitochondria persist. Stem cells remain dormant. Let me explain this with a simple analogy. Think of mTOR like a light in your pantry. When the light is on, your body thinks food is abundant. It keeps building and storing. When the light goes off, when insulin drops and mTOR quiets down, your body gets the signal that it needs to become more efficient. It starts cleaning up, recycling, and regenerating. The light going off is not starvation. It's a biological signal that unlocks maintenance mode. What the research shows is that lowering insulin is the green light for fat burning. A study cited in endocrine reviews confirms that keeping insulin low is critical for accessing stored body fat as an energy source. When insulin is elevated, fat cannot be released from your fat cells. It literally cannot be mobilized. The enzyme lipase, which breaks down fat for energy, is suppressed by insulin. This is why people can eat less and still not lose fat. If they're eating frequently throughout the day, insulin never drops low enough to unlock fat stores. Now here is the practical application. If you want to both burn stubborn fat and activate autophagy and stem cell regeneration simultaneously, you need to create a sustained window where insulin is low, not just for 12 hours, for 16 to 24 hours. And here's a critical strategy most people miss. What you eat before you start your fast matters enormously. Research published in the journal Nutrients found that people who began a 24-hour fast with a low-carbohydrate, high-fat meal reached nutritional ketosis, meaning they were burning fat and producing ketones, within 12 hours. Those who started with a high-carbohydrate meal hadn't reached ketosis even by 24 hours. So the meal before your fast is not irrelevant. Eat low-carb the night before. Think salmon, avocado, greens, Olive oil. Your body will thank you by entering fat burning mode twice as fast. Now, people often ask me, when exactly does the magic happen? Is it at 12 hours, 16 hours? Do I need to go longer? Let me walk through the science of what happens inside your body hour by hour during a 24-hour fast, because understanding this timeline will completely change how you think about fasting. Hours 0 to 12. After your last meal, your body begins burning through circulating glucose and glycogen stored in your liver. Insulin begins to fall. Around the 10 to 12 hour mark, depending on what you ate, your liver glycogen starts to deplete. Your body essentially runs out of easy gas and begins its first shift toward fat burning. This is also when early ketone production begins. If you started with a low-carb meal, as we discussed, this process accelerates significantly, hours 12 to 16. This is when the metabolic switch truly flips. What the research shows is that between 12 and 16 hours of fasting, insulin levels drop to baseline, glucagon rises, and your liver begins actively converting fatty acids liberated from your fat stores into ketone bodies. Ketones are not just a fuel source. They are signaling molecules. They reduce inflammation. They enhance brain function. They suppress appetite. They begin activating AMPK, the enzyme that triggers autophagy. Around the same window, your body starts to increase human growth hormone, HGH. This is critical. HGH is one of the most powerful fat-burning, muscle-preserving hormones in the human body. It tells your body, burn the fat, preserve the muscle. Don't break down your lean tissue. During fasting, HGH can increase significantly. Studies have documented rises of several 100% during extended fasting periods, essentially acting as nature's built-in protection against muscle loss. Hours 16 to 24. This is where things get deeply interesting. By 16 to 18 hours, most people are in full ketosis. Fat oxidation is the primary energy source. A 2024 study referenced in Nature Scientific Reports confirms that around the 24-hour mark, autophagy, cellular recycling, accelerates meaningfully, with cells beginning to identify and remove damaged components at a significantly elevated rate. This is when the night shift crew really gets to work. At 24 hours, you are burning fat, you are producing ketones, you are in active autophagy, your insulin is at baseline, your HGH is elevated, and your stem cells, as we are about to explore, are being primed for regeneration. Here's the practical protocol. Start your fast after dinner, say 7 or 8 p.m. Sleep through the first 8 to 10 hours. That's free. You're already doing it. Wake up, drink water or black coffee, and continue fasting through the morning and midday. By 7 or 8 p.m. the following day, you've completed a clean 24-hour fast. Break it with a nutrient-dense, moderate meal, not a feast. Now here's the section I am most excited to share with you, because it contains a finding from 2024 that fundamentally changed how we understand stem cell regeneration, and almost nobody is talking about it. In May 2024, researchers at Columbia University, led by Dr. Emmanuel Passaguet, director of the Columbia Stem Cell Initiative, published a landmark study in the journal Cell Stem Cell. The study examined aging blood stem cells, specifically hematopoietic stem cells, which are responsible for generating every single blood cell in your body. Red blood cells, white blood cells, immune cells, platelets, everything. Here's what they found, and it is genuinely remarkable. Old blood stem cells, aged stem cells, had accumulated metabolic damage driven by chronic inflammation in the bone marrow environment. Their regenerative capacity was significantly diminished compared to young stem cells. They were functionally aging out. But then the researchers did something simple. They put aged mice through a 24-hour fasting and refeeding cycle. Fast for 24 hours, then eat again. And what happened? The aged stem cells were nearly fully restored to the functional capacity of young stem cells. Their regenerative output, measured by their ability to engraft and reconstitute the entire blood system, was restored to levels comparable to young, healthy stem cells. The researchers described it as resetting the metabolic state of the old stem cells. Here's the critical insight that most summaries of this study miss. Fasting alone was not enough. It was the combination of fasting and refeeding, the cycle, that produce the regenerative reset. When they fasted without refeeding, the improvements were modest. But when they fasted and then ate again, something powerful happened. The refeeding triggered a transient surge in autophagy that acted like a metabolic reboot for the stem cells. It normalized their glycolytic flux, essentially restoring their energy metabolism, and unlocked their dormant regenerative potential. Let me explain this with a simple analogy. Think of your stem cells like a battery that's been left on the shelf too long. It holds a charge, but barely. You could leave it plugged in for a long time and it might slowly recover. But the fastest, most effective way to recondition an old battery is a specific cycle. Discharge it fully, then charge it back up. The fast is the discharge. The refeed is the charge. The cycle is what restores the battery. What this means practically: your refeed meal after a 24-hour fast is not just about satisfying hunger. It is a therapeutic signal. It is the moment your stem cells get the message to wake up and regenerate. This is why how you break your fast matters enormously. What the research supports: break your fast with a meal rich in high-quality protein to stimulate muscle stem cell activation, healthy fats to support ketone transition, and nutrient-dense vegetables for micronutrient replenishment. Think a bowl of omega-3 rich salmon with roasted vegetables and olive oil, or pasture-raised eggs with spinach and avocado. Avoid breaking your fast with sugar, refined carbohydrates, or alcohol. These immediately spike insulin, suppress autophagy, and interrupt the regenerative cascade you just spent 24 hours setting up. Now let's get specific about exactly how to do this right, because the difference between a 24-hour fast that transforms your health and one that leaves you exhausted, irritable, and abandoning the whole idea by noon is almost entirely in the preparation and execution. Let me walk you through the complete protocol. The night before your fast, eat a low-carbohydrate, nutrient-dense dinner. This is strategic. A clinical study published in Nutrients confirmed that starting your fast with a low-carb pre-fast meal allowed older, sedentary adults to reach nutritional ketosis within 12 hours, compared to those who ate high-carb meals who didn't reach ketosis at all during the entire fast. Your pre-fast meal sets your metabolic runway. Eat fatty fish like salmon or mackerel, a generous portion of leafy greens, olive oil, avocado, or eggs. Avoid pasta, bread, rice, potatoes, alcohol, dessert. During the fast, hours 0 to 24, here is what you can consume without breaking your fast: water, and drink plenty of it. This is essential. When insulin drops during fasting, your kidneys release sodium and water. If you don't hydrate adequately, you will feel fatigue, headaches, and dizziness. And many people mistake this for the fast being bad for them when it's simply dehydration. Black coffee in the morning, no cream, no sugar, is acceptable and may actually accelerate autophagy. Unsweetened herbal teas are fine. Plain sparkling water is fine. That's your toolkit. What you should avoid during the fast: flavored drinks, sweeteners, even artificial ones, protein shakes, broths with protein, or anything that triggers an insulin response or contains amino acids that activate mTOR. These will blunt or eliminate the autophagy response you're building. On the supplement side, several compounds have research support for enhancing autophagy and stem cell regeneration. Spermidine, a naturally occurring polyamine found in wheat germ, aged cheese, and fermented foods, has been shown in multiple studies to promote autophagy through a specific pathway involving EIF5A, a translation factor that helps muscle and blood stem cells regenerate. You can supplement spermidine directly or get it through dietary sources. Berberine, a plant compound, activates AMPK, the same enzyme that fasting activates, and can deepen the autophagy response. Magnesium supports cellular energy and is often depleted during fasting. Electrolytes, sodium, potassium, magnesium, are essential during a longer fast to prevent the fatigue and headaches that cause people to quit prematurely. Exercise during your fast. Light to moderate movement, a 30-minute walk, gentle yoga, mobility work, is excellent and can actually deepen autophagy by further depleting glycogen and lowering glucose. Avoid high-intensity exercise during the fast, particularly if you're new to this. Your body needs to adapt. Breaking the fast, the refeed. As we discussed with the Columbia study, this is just as important as the fast itself. After 24 hours, break with a moderate meal containing high-quality protein, 30 to 50 grams, healthy fat, and vegetables. Eat slowly. Give your digestive system time to re-engage. Don't overeat. The goal is to send a regenerative refeeding signal, not to eat everything in your kitchen. You've done the fast, you've broken it properly. Now, how do you maximize the stem cell regeneration and metabolic benefits in the days that follow? Let's talk about the foods that directly support stem cell health. Research in functional medicine and nutritional biology has identified several compounds that are genuinely stem cell supportive. Blueberries, specifically wild blueberries, are rich in pterostilbene and anthocyanins, compounds that reduce oxidative stress in stem cells and support their longevity. Dark leafy greens like spinach, kale, and arugula are high in folate, which is essential for DNA synthesis and stem cell division. Fatty fish, salmon, sardines, mackerel, provide omega-3 fatty acids that reduce the chronic inflammation which, as the Columbia study showed, is the primary driver of stem cell aging in the bone marrow environment. Fermented foods, kimchi, sauerkraut, kefir, support gut stem cells and the intestinal lining, which renews itself every 5 to 7 days in a healthy gut. Walnuts and flax seeds provide alpha-linolenic acid and resveratrol adjacent compounds that support mitochondrial stem cell function. On the lifestyle side, sleep is non-negotiable. Growth hormone, which accelerates both fat burning and stem cell activation, is primarily secreted during deep sleep between roughly 11 p.m. and 3 a.m. If you're sleeping 6 hours or less, you are cutting off the regenerative signal before it can complete. Aim for 7 to 9 hours with a consistent bedtime before 11 p.m. Cold exposure, even a 60-second cold shower at the end of your morning shower, has been shown to activate brown adipose tissue, increase norepinephrine, and support metabolic flexibility. It's a simple, free addition to your protocol. Stress management is not optional for stem cell health. Chronic cortisol elevation from psychological stress, overtraining, sleep deprivation, or inflammatory foods directly suppresses immune stem cells and promotes what researchers call stem cell exhaustion. Even 5 to 10 minutes of daily diaphragmatic breathing, meditation, or quiet time is enough to meaningfully lower cortisol and create a more favorable hormonal environment for regeneration. Movement beyond the fast. Resistance training 2 to 3 times per week has been shown to stimulate muscle stem cell activation, specifically satellite cells, which repair and grow muscle tissue. High-intensity interval training, when done at appropriate times, elevates HGH and improves metabolic flexibility. Walking, especially after meals, is one of the most underrated tools for insulin management. Even a 10-minute walk after eating can reduce post-meal glucose spikes by 20 to 30%, which means less insulin, less mTOR suppression of autophagy, and a faster return to a cellular maintenance state. The practical weekly protocol that synthesizes everything we've covered today: eat a low-carb, nutrient-dense diet throughout the week. Practice a 16.8 intermittent fasting window daily if you can. Once a week, or once every 2 weeks, extend to a full 24-hour fast with proper preparation and a strategic refeed. Support your body with the compounds that support autophagy and stem cell function. Prioritize sleep, move your body, manage your stress. This is not a complicated protocol. It is a return to the biological rhythms your body was designed for. Let's bring it all together, because today we covered a lot of ground. Here is what the science is telling us in the clearest possible terms. Your body has an extraordinary built-in capacity to regenerate, to repair damaged cells, renew stem cells, clear out metabolic debris, burn stored fat, and reset its biological age. That capacity is not lost with age. It is not gone after decades of poor eating habits. It is simply dormant, waiting for the right signal to be activated. And that signal is a drop in insulin, a suppression of mTOR, and an activation of autophagy through fasting. We learned that autophagy, your cellular self-cleaning system, is the master regulator of stem cell health. When it's active, your body removes damaged proteins, recycles worn-out mitochondria, and creates space for new, functional cellular structures. When it's chronically suppressed by constant eating and elevated insulin, your cells age faster, your stem cells lose their regenerative edge, and fat becomes locked in storage. We learned that the timeline of a 24-hour fast creates a precise sequence of metabolic events. Insulin drops, glycogen depletes, ketosis begins, HGH rises, autophagy accelerates. That together constitute one of the most powerful anti-aging and fat-burning protocols available to a healthy adult. And we learned from the 2024 Columbia University research published in Cell Stem Cell that aged stem cells can be nearly fully restored to the regenerative capacity of young stem cells through a single cycle of fasting and refeeding. Not surgery, not stem cell injections, a 24-hour fast followed by a strategic refeed meal. We learned how to do this properly, eating low carb the night before, staying hydrated during the fast, using spermidine, berberine, and electrolytes strategically, breaking the fast with high-quality protein and healthy fats, and supporting the protocol with quality sleep, movement, and stress management. This is not extreme. This is physiology. This is your body doing exactly what it was designed to do when you give it the right conditions. So here is your challenge. And I mean this as a genuine invitation, not a sales pitch. Try it for one day. Pick a day this week. Eat your low-carb dinner tonight. Set your fasting window. Wake up, hydrate, move, and let your body do what it knows how to do. Break your fast 24 hours later with a clean, nourishing meal, and pay attention to how you feel, your energy, your mental clarity, your hunger patterns, your inflammation. Because once your body experiences what happens when autophagy turns on, when fat becomes fuel, when your cells begin to clean house, you will understand why this practice has been at the center of human health and longevity traditions for thousands of years. The research has now caught up with what ancient wisdom has always known. Cycles of fasting and feasting are not just spiritual practices, they are cellular medicine. If this video added real value to your health journey today, if you learned something that changes how you think about your body, your energy, or your aging process, I'd ask you to do one simple thing: like this video and subscribe to this channel. Every day, we publish content just like this: practical, evidence-based, functional medicine insights that you can actually use to live longer, feel better, and take back control of your health without relying on medication. Your biology is not your enemy. It is your most powerful ally. And now you know how to work with it. I'll see you in the next one.